So the next example we're going to look at is also in my live lessons GitHub repository in the Java 8 folder, this time in the ex39 project. So if we come over here to IntelliJ, you can see we're in the ex39 project. Here's the ex39 file. And this particular program demonstrates a whole bunch of different ways to implement an AtomicLong abstraction, including using a Java StampedLock, a ReentrantReadWriteLock, good old-fashioned Java synchronized statements, something a bit newer called VarHandle, and then finally the AtomicLong class itself. And this is going to give us a chance to see how all these implementations work, and it'll also give us a chance to sort of do a bake-off to see which one runs best under which circumstances. So here is the way the tests work. We're actually going to run 10 million iterations for each test for each different type of reader or writer. We're going to have reader threads and writer threads, and we'll look at that in a second. And we're going to have quite a number of reader threads. We're going to have 20 reader threads, and I'll talk more in a second about why we choose to do that. We're going to take a look at all these different AtomicLong implementations. But before we do that, let me first just give you a flavor of what it is we're trying to do. So here's an interface called Abstract AtomicLong, and essentially it defines 5 methods that are a subset of the AtomicLong class. It's part of the Java class library in the concurrent atomics package. And what it has is it has a get method, which is just going to read the value of the long atomically. And it has a decrement and get, and a get and decrement, or get and increment rather. And you can see here that we also have an increment and get a get and decrement. And so these are methods that are pretty much the Java equivalents of or postfix increment and prefix increment and postfix decrement and prefix decrement that you would expect with C++ or C or even Java for built-in types. This is the way we do that with the atomic operations. So those are the APIs. There's lots of other methods we could do, but these are the key ones to show off. So armed with that knowledge, we're then going to go ahead and make a bunch of implementations, which we'll look at here in just a second. And then we're going to test each of them. We're going to test each of these implementations by calling the run test method for the different kinds of atomics. And we all give them the same initial value. We record their names so we can print out the results when we're all done to see how they perform. So let's go take a look at the run test. So the run test method takes the implementation of abstract AtomicLong as an interface, so they can all be used in a common way. And it takes the name of the test. The first thing we do is we garbage collect everything before we start to time the test execution period. We use our run timer time run method. We've seen this many times before. It's a little utility class I use a lot for testing, where we're going to start the timer, run whatever we're going to be running, and then stop the timer. And then we take the total elapsed execution time and we stick it into a map. So what we're going to do is we're going to test each of these things, and we're going to take each of these AtomicLong implementations and pass them to the test AtomicLong test method. And let's go take a look at that. So here's test AtomicLong. This is really cool. So it's going to use a few other features that we're not going to talk about in this class till a little bit later, but you can always go watch the videos if you're curious. We're going to use something called a phaser. And a phaser is a very sophisticated barrier synchronizer. And we're going to use this phaser to ensure that all the threads we create all begin at the same time. We want them all to start up because we don't want to bias things by having something start earlier and something start later. So we make ourselves a phaser. We then make ourselves a list of threads that are going to run either writer operations or reader operations. And then we take that list of threads, which is initially empty, a particular AtomicLong implementation, the entry barrier, and the number of readers, and we call the make readers method. Here's make readers. So you can see that make readers is going to iterate for I equals 0, I less than the number of readers. And each time through this loop, it's going to make a new thread, add it to the list, and the thread's runnable is going to perform read operations only. And all it's going to do is it's just going to sit there just reading, calling get just to see what the value is. So it's just reading and seeing how long it takes to do a read. Here's what make runnable looks like. Make runnable uses the entry barrier and says, wait for all threads to be ready to run before any thread runs. And that's what the arrive and await advance method does. It's essentially a way to tell the barrier, I'm here. And when everybody who we've told to expect has shown up to the party, they can all start to run. Once we're given the green light to start running, we iterate for S max iterations, which in this case is 10 million times, calling the run method in the runnable. And you can see that here that the run method is just calling the get method on whichever implementation of an atomic long we're dealing with. That this is just allows us to do apples to apples comparisons. So that's what make readers does. Let's now go take a look at make writers. Make writers takes that same list of threads that has all the readers now, the same abstract atomic long and the same entry barrier, except what it's going to do is it's going to go ahead and make a list of writer threads. So this is the writer thread list. And it's going to have 4 elements, one for each of the different operations defined on an abstract atomic long. Increment and get, decrement and get and increment, get and decrement. So we basically make runnables for each of these things that are just going to do those operations. We stick them into a list. So we have a list of threads. And then we go ahead and add all of those onto the end of the threads list. So we've got, in this case, 20 reader threads. And then we've got 4 more threads, each of which is doing something separate, increment and get, decrement and get, and so on and so forth. Okay, so that's what make writers does. Now what we're going to do, now we've got everybody registered, we're going to say, how many threads do we have? Well, we've got, in this case, 24 threads. So we're going to bulk register 24 as the size of the entry barrier. And all that means is when the method that we saw down here, which is the one that's called arrive and await advance, after 24 of these things are called, in that case, then each of those threads can actually start to make forward progress. So next thing we do is we iterate through each thread and we tell them to start. So all the threads are now up and running. Once the 24th one has started and it calls await, arrive and await advance, then they're all off to the races. They're all off running at this point for however long it takes to run. And then the main thread uses the thread join barrier synchronizer to wait for all the threads to exit, for all the threads to finish running. And once again, we use a little clever exception laundering here to convert the stupid checked exceptions into runtime exceptions so that this code is a lot cleaner than having to throw a try-catch block around this. When all is said and done, there should be a value of 1 in the atomic long because it's going to be incremented and decremented 10 million times. And so it should end up with the count of 1, assuming that everything works correctly. And then we print off what we got and we're done. So that's the main program. Let's now go ahead and take a look at the different implementations. And some of them are real simple. Some of them are really sophisticated.